Okay, ready. I'm ready now.
X plus y equals negative 13. And then in parentheses, x minus 4 squared plus, in parentheses, x plus 10 squared equals 25.
Is it y or x?
Oh, y. I'm sorry, it's y.
Y plus?
10 squared equals 25.
Okay. So we had a problem like this. Am I correct?
Yes, but I just...
I'm just checking my memory.
I'm
When you get to my age, every now and then you have to check your memory.
I don't think it was this long.
Okay. Very good. So obviously there is no other chance because the variables are not the same, right?
Right.
There is no way I can eliminate. So I have to solve this equation. It doesn't matter at this point because both coefficients are 1. If you solve for x or y, it's up to you. Which one do we want?
X equals negative y minus 13.
Very good. Perfect. So then I have to replace this x in the second equation by negative y minus 13. Okay? So I have negative y minus 13 minus 4 is negative 17 squared plus y plus 10 squared equals 25. Is this okay so far?
Yes.
Okay. So now I think we talked about it, but again, I'm checking my memory. So if I have y plus 17 or I have negative y negative 17, when I square, I will get the same thing. I think I mentioned this. So here's why. Because I factor out negative 1, and I have to square. But I square negative 1 as well. Okay? So I'm only pointing that out because I don't want to see any negatives in here. So once both of them are negative and you square, all terms will be positive because of this reason. I can factor out inside negative 1, and then negative 1 squared will be positive 1, and I'm still left with y plus 17 squared. This will not happen if only one of them is negative. If this or this is negative, then the middle term will be negative if either one is negative. But since in this case both are negative, just imagine that you factor out negative 1. Negative 1 squared will be 1, and then you're still left with y plus 17 squared. This is just a parenthesis if you want, just a talk. So when I square this, how many terms do I get?
3.
Thank you. So the first term squared is y squared plus 2, exactly, times the first times the second, y, and plus?
289.
Okay. Plus, when I square y plus 10?
Y squared.
Yes, indeed.
Plus 20y.
Very good.
100 equals 25.
Very good. Minus 25 equals 0 because I know now that this is quadratic and I have to set it equal to 0. Agreed so far? Okay. So now I have to combine like terms. Acceptable? So 2y squared. And then I have to combine these two, and I have 34 and 20. So this is 54y. And then I have 100 minus 25, which is 75, and 75 to be added to 289. So 289 and 75, is it?
Yeah, 364.
Very good. You know what I'm going to do next? Of course, make it as simple as possible. Plus 27y plus 182 equals 0.
Oh! Okay. Notice I missed that step.
Well, it's not mandatory, but it makes your life easier. So always remember, if I'm hoping that you get more than that out of this class. But always remember, simplify and factor. Everything that is possible, you should. If you can't simplify, then it's a different story. Yes, Danielle, yes, let's hear it.
Yeah.
Oh, I'm sure it's important.
No, it's okay.
So always simplify because you make your life easier. Still, I would not work with these numbers. I would not factor. I would use the quadratic formula. So then y equals negative 27 plus or minus 27 squared minus 4 times 182 divided by 2. So I'll put it in parentheses, negative 27 plus the square root. In parentheses, 27 squared minus 4 times 182 close the parenthesis, close the outside, and divide by 2. Here's what I just did. Negative 27 plus the square root, blah, blah, blah. So I got negative 13. I copy. This is so much easier for me with a calculator. And I get the other one with overwriting the plus into minus. So I got negative 13 and negative 14. Don't worry, we'll check it anyway. So then y equals negative 13 and y equals negative 14. That's good, but that's not good enough, right? I have to come back in here and get x. So when y is negative 13 with minus in front, negative 13 would be with minus in front is positive for 13, and minus 13 is 0. And then with negative 14, I get 1. X equals 1. So the ordered pairs are 0, negative 13. It appears so. And 1, negative 14. Do I trust this? No. And if I do, even if I do, I should go back and check. You never know. So 0, negative 13 first. Does it work? Have you checked? So 0 minus 13 is negative 13. That's correct. 0 minus 4 is negative 4 squared is 16. Negative 13 plus 10 is negative 3 squared is 9. Of course, it's 25. So then I will say this is a yes. Now I'm checking 1, negative 14. So 1, negative 14, and 1, negative 14. Okay, so 1 minus 14, negative 13, correct. 1 minus 4 is negative 3. Negative 3 squared is 9. And negative 14 plus 10 is negative 4. Negative 4 squared is 16. I get the same thing. So I will say yes to both. Is this better?
Yes, thank you.
Okay, so
had no clue what I was doing.
that's okay.
Well, I just missed this stuff.
We always get through that. So yes, I'm ready for anything you want.
There's this one.
Yes, any question?
Gauss-Jordan.
Gauss-Jordan, very good. Let's take a look at Gauss-Jordan.
It's the 5x.
So it's this one, the 5x plus 3?
Yeah.
Okay, very good. Let's work on it. Good question. Let me copy it. And please check. I'm going to copy it, and as you know, sometimes I copy incorrectly. It's happening before. It happened before. It may happen again. I hope not, but equals 5. So I'm going to read it back to you. Just make sure. From wherever you copied it, are you sure you copied it correctly? Is that a yes?
No, it's yeah, I see there. X minus 3y plus z.
Yeah, that is.
Oh, okay. I thought it was
That's right.
Okay, so let me read this back to you. 5x plus 3y minus 3z equals negative 9. Is that correct? X minus 3y plus z equals 13. And x minus 2y equals 5. Very good. Thank you. So is this system? Yes.
I just have a quick question.
Please.
So when I was rewatching the lecture on
Yes.
matrices,
Yes?
I heard you mention like we can do matrices in a calculator. Like, are we ever going to do that, or are we just going to use Gauss-Jordan?
There is a method called the inverse inverse matrix method. It works only if the system has a solution. If it doesn't have a solution, we cannot apply it. And that's not going to give anything. And yes, there is a method that I can show you in the calculator to check your answer if you want.
Okay.
But once you get the solution, you already know what it is, but I can also show you how to do it with a calculator. With pleasure. Okay. But there is a theory behind it that I have to explain. But if you just want the final answer, how to check it in the calculator, I'll show. Good. So we have the augmented matrix. 5, 1, 1, 3, negative 3, negative 2, negative 3, 1, 0, negative 9, 13, 5. And if you remember, we cannot deviate from the steps. 1 and the corresponding zeros. 1 and the corresponding zeros. 1 and the corresponding zeros. This has to be carved in stone. We can't go back and destroy anything. Ready? Okay, so I would recommend, let's swap these two. We can swap these two. It doesn't matter. I really don't know. Maybe the last one should be the first. I have no idea. So which one would you like?
The third one.
Okay, very good. So you want row 1 to become row 3 and row 3 to become row 1. Yes? Okay, perfect. So 1, -2, 0, -9. 1, -3, 1, 13, and 5.
I put
It's
5.
5, not -9, top row. 1, -2,
Oh, yeah.
0, 5.
Oh, thank you. Thank you.
That's positive.
And it's positive. Thank you. 5, 3, -3, -9. Correct. Thank you. I was going to check again, but thank you. Always stop me if you see something because I may not see it. So 5, 3, -3, -9 is correct. 1, -2, 0, 5. 1, -2, 0, 5 is correct. Good. So now we do have the one that we were looking for, this one. And my next step is to establish or form the zeros here. Which row do I have to use?
Row 1.
Yes, row 1, we multiply it by something and add it to row 2, and row 1 multiplied by something and we add it to row 3. What do we need to multiply row 1 by to eliminate this?
-1.
Perfect. What do we need to multiply row 1 by to eliminate this?
-5.
Awesome. Okay, which row do I copy? Because now I'm using it and it's not going to change.
Row 1.
At this stage, it will not. Very good. So let's do this together. 1 times -1 plus 1.
0.
-2 times -1
2.
minus 3.
-3.
Oh, I like it. 0 times -1
0.
plus 1.
1.
5 times -1
-5.
plus 13.
My number is not either.
1 times -5 plus 5.
0.
-2 times -5
10.
plus 3. 0 times -5
0.
minus 3.
-3.
5 times -5
-25.
minus 9. Well done. Is this okay so far? Good. I don't have to swap anything because my next step is right here, but I do have to do something.
You have to divide it.
Divide or multiply row 2 by -1. Perfect. Next step. One, -2, 0, 5. 0, -1, I'm sorry, +1, -1, -8. 0, 13, -3, -34. Which row do I have to use now?
2.
Yes. Have to use row 2, and what do I need to multiply to eliminate something in row 1?
2.
What do I multiply row 2 by to eliminate something in row 3?
13.
Awesome. So see, once you see it, you can go back. Right. Which row do I copy now because it will not change?
2.
0, 1, -1, -8. Now watch this. If I, by any chance or by any mistake, if you want, if I destroy this, I'm going backwards. I don't even look at this. Okay, so be very careful. This is done. So we are moving forward, meaning to the right. Okay, ready? 1 times 2 minus 2.
0.
-1 times 2
-2.
plus 0.
-2.
-8 times 2
-16.
plus 5. Perfect. We're such a good team. 1 times -13 plus 13.
0.
-1 times -13
13.
minus 3.
10.
-8 times -13.
I don't know.
104.
Very good. Positive. And minus 34. 70. Remember, we're not looking back. Where is my target point? What is my next step if you want?
Divide row 3 by 10.
That's it. Which row do I have to use now? And I multiply by something to edit to row 1, and multiply by something else to edit to row 2, and this is the final step. Now, I don't have anything against the method in the book, but we finished the problem in 1 with a swap. 1, 2, 3, 4, 5, 6 steps. The book does not do 2 steps in 1, like I'm recommending, and it drags on forever. It's on pages and pages. So if you understand this method, use it. If you don't like it, use the other one. I'm fine. Okay, so what do I need to multiply row 3 by to edit to row 2 and get a 0 here?
2.
And to get a 0 here? Very good, awesome. Final step. One times 2 minus 2.
0.
7 times 2
14.
minus 11. 1 times 1 minus 1. 7 times 1
7.
minus 8.
-1.
Okay. We hope that the solution is 3, -1, 7. We always go back and check. It's so easy to make an error. Okay, so 3, -1, 7. 3, -1, 7, 3, -1, 7, 3, -1. 15 minus 3, 12. 12 minus 21. 12 minus 21, -9. 3 plus 3, 6 plus 7, 13, correct. 3 plus 2, because it's -2 times -1, 5, correct. Only now I can say yes with a sigh of relief. Because trying to find a mistake in the maze is difficult. I would have probably started from scratch, especially on a test situation. Kind of difficult to go back and find the error. Very good. Any questions? Okay. Anything else? Is there any? Yes, please, Amanda.
Can we do a log?
Yes, I'm ready.
Okay, so it's log base 4 x plus 6. And log base 4 x plus 3. Wait, log base 4 x plus 3.
Is it a plus? Is it?
Oh, it's a plus, sorry.
I'm sorry, I didn't know what to. So log base 4 of x plus 3 equals 1. Very good. So I recommend writing domain and common domain and then condensing. So what is the domain of this? What do I have to write for this function to exist?
-6.
I have to write a condition. What is the condition that I have to write and solve? I have to write x plus 6 greater than 0, which will result into greater than -6. Very good. For this one, what do I have to write? Is this clear? Okay. So then from here I have x greater than -3. What will be the common domain? If you say I can see it, graph it, I'll graph it. If you see what the common domain is, then I'll write it. Yeah, is that clear? From -6 to infinity and from -3 to infinity. So the overlap is -3 to infinity. Do we agree with that? Yes? Okay. Do I have to show anything? It's okay if you say yes. Okay. So -3 to infinity. See if the equation doesn't have a solution that is greater than -3, I will say no solutions. Good. So now I have to condense the left-hand side. The sum of two logs comes from
Multiply.
Yes. So how do I write it?
Log base 4
Yes,
x plus 6. And then times 0 x plus 6.
indeed. This is a log equation that is equivalent to an exponential one. Can anyone give us the exponential equation that this is equivalent to?
X squared.
4. But I'm sure you're writing it the same way. So 4 raised to this power is this product. 4 to the first, I don't have to write first, equals x plus 6 x plus 3 times x plus 3. So now I distribute x squared plus 9x plus 18 minus 4 equals 0. Quadratic. I hope that I can easily factor. If not, I will use the quadratic formula.
Did you just FOIL? Is that how you got that?
Yeah, so it's x squared plus 3x plus 6x is 9x plus 18. There is no other way, yes.
X plus 7, X plus
Very good. X plus 7, x plus 2, which means x equals negative 7 and x equals negative 2. So, conclusion then.
I mean, x equals negative 7.
Of course, it's not in the common domain. It cannot be accepted. So the only one that is accepted is negative 2. Any questions? Any questions? So remember, you have the other option. I personally don't recommend it, but it's acceptable. You can say, I'm not going to state a domain. I don't want to do that. But if you don't go back and check, you cannot get full credit. So it's up to you. I recommend a domain. It doesn't take that long. And I'm hoping that once you determine the domain, the common domain, then you will say, okay, I have to go back and double check. And not forget to check back in the original problem. I think it's sometimes more work to go back and check than state a common domain. Good, next problem. Anything?
So number 15 on review.
Yes, anything.
I just forget how to do the breaking point. So if C of x equals 18,750 plus 19x, and then R of x equals 49x.
So the break even is when the cost equal the revenue. So you have 18,750 plus 19x equals 49x, or 18,750 equals 30x, and you divide. The break even means we're not making any profit. Every penny we get on revenue as revenue goes out as cost. So what do we get? It's 625, whatever product.
Thank you.
Sure. Anything else? So some of you were not here when I said that I I put a hold on room Randall Mills 401 on December the 8th between 11 a.m. and 12:30 p.m. So this is not a review in the sense that I will be lecturing. I will answer your questions if you have any. So please do come if you have questions.
Can you do number 10 on
Yes.
the review?
Yes, yes. What does number 10 say?
9. And then
Power.
power of x plus 4 equals 81 power x minus 2.
Good, very good. So what type of equation is this? Obviously, it's an equation. What type of equation is it? Exponential indeed, because the variable is the exponent. Good, so I'm trying, if remember, the first thing that I look at is to check whether I can present both sides with the same base. Because if I can, I don't really need to involve the inverse function, which is applying log. It's not going to be a need to. So as you know, I'm not a fan of non-prime numbers, but in this case, 9 and 81 work with 9, which is not a prime number. So 9 raised to x plus 4 equals 9 squared raised to x minus 2. So once you notice that both sides can be presented with the same base, I think the equation becomes easier to solve. I think, because you don't have to apply log, which is the inverse function, right, of exponential. So now you have to remember how to raise a power to a power. Copy the base. What happens to the exponents?
Multiply.
Correct. So what do I have here then?
2x minus 4.
Very good. So now in this case, remember, we are not crossing out, we're not simplifying, we are not erasing anything. We are thinking in these terms. Two numbers are equal, and they have the same base. What has to happen to their exponents? They have to equal each other, correct. So this is x plus 4 equals 2x minus 4. Linear, I move to x. Negative x equals negative 8. X equals 8.
I went down to 3. Still got the same number, so.
So you apply log. Yeah, this is what I like. Absolutely. I do like 3 squared on this side, x plus 4, and then 3 to the 4th on this side to x minus 2. Yes, this is how I like it, with prime numbers. But it worked with 9, so I said okay. Very good. Next question. Anything else you worked on or anything else you'd like to work on?
Can we do number 11?
Please. And what does it say?
So it's e raised to 2x minus 3 minus 7
7?
equals 12126.
12126. Very good. What type of equation is it? Very good. Exponential. What do I have to do first? Yes, get rid of the 7, meaning I'm adding 7 to both sides. E to 2x minus 3 equals 12133. Now this is completely cleaned up. I could never ever present both sides with the same base. I wish I could, but I can't. So 12133 can now be presented with base E. So my only chance to solve this equation is if I involve the inverse function to bring the function that brings the power down. And there is only one function that brings the power from an expression down. Which function is that? Correct. Or log or any log. But it's wise to use natural log because this base is E. What is the base of natural log? E, that's why. So we apply natural log to both sides. Will you get the same answer if you apply log to both sides? Exactly true, yes. So this is 2x minus 3. One more time, I should write times natural log E. So parentheses times natural log E. Why don't I write it? Because natural log E is, that's it. 12133. Now this is linear. I move 3 and divide by 2. 3 plus natural log 12133 over 2. How? How could I simplify? No, please don't say it. Please don't say it. There is nothing we can do here. We cannot touch the number inside. These are two terms. We cannot simplify in any way, shape, or form. We can only simplify factors.
Because adding the natural log to the 12.133, that makes it a completely different.
No, even if I didn't have the natural log, I would have had to add them and then divide by 2.
Yeah.
But I cannot add them.
Right, that's what I'm saying. You
Right,
can't add
right,
the 3 to
right, right. I thought you were trying to simplify something with 2 in the denominator.
No.
My apologies, I misunderstood. No, so we cannot. The only thing we can do is to approximate natural log. But this is what we want because this is the exact. Now, if the problem is asking us to approximate, then I will say x approximately, and I'll put it in my calculator. Don't forget parentheses around the top. Very good question. Thank you. Natural log 12133. Close the parenthesis for natural log. Close the parenthesis for the numerator and divide by 2. Be very careful. 6.20. And yes, you can always go back and, what was it, 6.02, correct? No, 20. It was 20. So now you can always go back and check. How would you check this number, right? You're going to plug it in here. So if you want to check, here's what I would do. I will write E, this E. You know me, I would put parentheses around the power. 2 times the previous answer, the whole answer, minus 3, close the parenthesis, come down from the power, minus 7, and minus 12126. When I hit enter, what should I get?
0.
Of course. And I do get 0. Very good. Amanda, is this okay? Okay, other questions for me? Anything else you would like to see, you would like to work on, anything?
Can you use number 17?
Correct, yes. What is it?
Y
Yes?
is greater than or equal to x squared minus 36, and then x minus y greater than or equal to -6.
Good. So this is a system of inequalities. One of them is non-linear, the other one is linear. I start with the equation y equals x squared minus 36. And by now we already dream about this one, right? We've seen it so many times. Quadratic, and where is it shifting?
Where, oh, it's,
Right?
Left.
No.
right.
It's moving down.
Exactly, because I'm not changing x, I'm changing y. Correct. It's down 36. But I still have to find the x-intercepts. So when y equals 0, I have x squared minus 36 equals 0. We can dream about this now, right? X squared equals 36 means x equals,
Plus minus 6.
very good, awesome. So when I graph it, I will say 3, 6, 3, 6. And then here I'm going to say 10, 20, 30, 40. So here's the graph. Do I graph it as a solid curve or as a dashed curve? Very good, awesome. So this is y equals x squared minus 36. This is not the inequality. I will use the origin to check the inside, 0, 0. Is 0 greater than or equal to negative 36?
Yes.
Yes. So I will have to shade in the inside. Now, everything inside, including points on the curve, represents y greater than or equal to x squared minus 36. So if I pick points from here or on the curve, they will verify the first inequality. That's why all this region, including points on the curve, is this. Points on this curve is this equation. So now the other one will be just a line, x minus y equals negative 6. When x is 0, y is, very good, so 0, 6. When y is 0, x is, very good, negative 6, 0. So negative 6, 0 is here, and 0, 6 is here. I have to stop and identify whether I will be graphing a solid line or not. Awesome. X minus y equals negative 6. Okay, so now I choose the origins, meaning that I'm checking the bottom region, 0, 0. 0 greater than or equal to negative 6. If you say true, I will shade in this. If you say false, I will shade in the above.
It's true.
True indeed.
How did you get the points on the x-axis?
This point,
Like the ones before that one.
these ones?
Yeah.
Okay. So this is graphing a line using the x and y intercepts.
So you just use 2, but it would really be 6, right?
Yeah, like you did 3 and 6, like the way you numbered it.
Okay,
she
yeah, I get it now.
Like you did 3, like the first line equals 3 and the second one is 6.
Yeah, yeah. So yes, this is 3. Yes, I'm sorry. This is -6, and this is 3 and 6. Yes, my apologies. I should have written my mistake. Sorry about that. Is that okay?
Yeah.
Sorry. Okay, so now all this red region, including points on this line, represents solutions to this. This is not the line. The line is just this. So now I want to find the area where these colors exist, red and blue together. That's where the ordered pairs that verify both inequalities at the same time will be found. So do they overlap, the blue and the red? This line, this curve or function, and everything in between. This is both. Very good question. Next question, anything else you want to work on? Anything you tried, anything you'd like to review? Anything?
Number 22.
Yes.
It's 4 plus 6, 4 plus 10 plus 16, plus.
They have to be 3 dots. By mistake, I put 4.
In parentheses, 6n minus 2.
Okay, so we want to write the summation notation. So we have to have an index. Doesn't matter. You can use I, J, K, any index you like. Let's say we use K. And we have to have an expression, and we have to have a top limit. So this is the index. This will be the lower limit, and this will be the upper limit, and this will be the expression in which when I plug in the number that you're going to tell me here, I will get this. When I plug in the next one, I will get this. When I plug in the next one, I will get this. When I plug in the last one, I will get this.
Oh, so for the index will be 1
Okay, the lower limit 1. And how far do I go?
to n.
To n indeed. So let's see what we have in here. 6k.
Minus 2.
Good. So when k is 1, do I really get this first term? Good. When k is 2 plus, do I really get this term? When k is 3, do I really get this one? And when finally when I finally say k is n now, do I get 6n minus 2? That's all.
Can we do another one like that?
Yes. Do you have one, or should I find one?
I don't know.
Okay. I thought that maybe you had something. If not, we'll open on page, and you choose from there if you want. So this is in 8.1, page 752. Let's look at, I think we did them all, but let me look at the end of the chapter. Maybe they have more examples at the end of the chapter from this section. Let's see. 8.1. No, they don't. Nothing special, but we can still choose one. So here it is. 4 to the third plus 5 to the third plus 6 to the third plus ... plus 13 to the third. Let's use this time j as the index. It doesn't matter. Look carefully and see what changes. See where the lower limit should be, where the upper limit should be. So what is this and what is that?
1 and 13.
So if I put 1,
It's 3, right?
Oh, 4.
I would put 4.
Oh, okay,
Yes.
it starts with
4 to 13. Okay. There is more than one option.
Oh,
There is more than one option. So let's say 4 to 13. And what will you write? What should the expression be so that when I plug in 4, I get 4 to the third plus? Yes, that's it. So when I plug in 4, I get j to the third, 4 to the third, plus when I plug in 5, I get 5 to the third, plus when I plug in 6, I get 6 to the third, dot, 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 and I stop at 13, 13 to the third, because that's the last term.
oh, so the lower and upper limit is like the lowest thing that changes?
Yes.
And the upper limit is the highest thing that
Exactly.
changes?
Exactly. Yes. So see here, k was 1, right? So in this expression, when k is 1, I will get the first term. When k is n, I will get the last term. Here, when j is 4, I get the first term. When j is 13, I get the last term. And everything else in between. Very good. Good questions. Anything else?
Can we
Yes.
do- Can we do number 23?
Yes. What does it say?
50 factor over 500.
50 factorial over 500? Okay, that's the only chance we have is the calculator. No one can do this by hand. If you start now and stay in this room for the next year, you'll probably be able to finish it. I'm kidding. It's very cumbersome. So number 4, so I have 50 factorial divided by 500. So 6.0828, and there is an e in there, times 10 to the 61st power. So 6.0828 times 10 to the 61st. So why is that? Because you have to multiply 50 by 49, by 48, by 47, by 46, by 45. Yes. Good. Very good question. Anything else? Anything else?
Can we do number 2?
Yes. Which says what?
It's a compound interest formula.
Yes. I'm ready.
I'm handing Jeremy this.
Oh, I know the formula, so just give me the amount.
Let's see.
So A of t is P1 plus R over N raised to NT, and the other one is PE to RT.
So the value of the investment was 25,000 for 3 years at an interest rate of 5%. If it's compounded semi-annually, quarterly, and monthly.
Thank you.
And continuously.
Okay. I recommend putting this formula in the graphing calculator as 25,000 because this changes. I make this into x. So 1 plus 0.05 over x raised to 3x. So I recommend that. So let's do that. I'm bringing up my system. Run. Thank you. Okay, so in y equals, I have to change this table set. It goes to default all the time when I turn it off. So in y equals 25,000, in parentheses, 1 plus 0.05 divided by x, close the parenthesis, put the power, and you know me, I have to have parentheses, 3x, close the parenthesis. It may work without, but I won't take the chance myself. It's up to you. Any questions so far?
I have a question.
Yes,
So, why are you putting X?
this is the variable that changes from 2 to 4 to 12. That's my x.
Okay.
So I can immediately use the formula and get all the 3 results.
But the first, it's R over N and then raised to NT.
Yes. So n is x and t is 3. So everywhere I see n, I put x. I put x because I would have put n, but the calculator doesn't have n.
But why would, sorry, never mind. I wasn't looking at,
That's okay.
I thought you didn't put
The power?
5.
Okay. So now we go to second and table. You do not have to do this, 2, 4, and 12. The reason why I do it is because I don't want to repeat the same process 3 times.
Yeah.
I put in the function, I call n the variable, and the variable changes from 2 to 4 to 12. But you can do the same thing 3 times, and you get the same answer. Yeah, that's fine too. But I won't do that if I know a different way that it's easier. And it's, I think, more acceptable, but it doesn't matter. There are so many different ways to the same goal. So 28992.34, then scroll down to the next one, 29018.86, and then to the last one, 29036.81. Yes, how can I help? What's happening? Jeremy.
Oh, she's trying to figure out how to ask for the change from
Okay.
doing it.
Yeah, the second and table set. Very good. Any questions?
And we would just list those are our answers.
Yes, but this is just for the compounding twice, 4 times, and 12 times.
Yeah, you have to do the different.
For the continuous, there is no point in putting it in because there is only one calculation. So I will put 25,000 E, so second and E, and in parentheses I will put NT, which is 3, RT, sorry, 0.05 times 3. There is no N here. And press enter, and I get 29045.86. So a continuous 29045.86. So yes, we have to give the cents. And since this is 6, I will have to round 85 to 86. Very good.
What was that last number?
29045.86. Any questions?
So
And
for
yes,
the first
yes,
3,
yes,
the
yes.
First, like the semi-annual, quarterly, and monthly, you
Yes.
use the first formula, but for the second,
If there is n involved, it's n times. If there is no n involved, it's continuous.
okay.
There is no n for continuous. Means every second. Is that okay? Good. Other questions, please? Anything else you would like to go on?
Oh,
Yes, Jeremy?
Log
Yes.
x plus
I was looking at you and I was, oh, log. Oh, log. Okay, log.
X plus 3 in parentheses, and then minus 1. That's it. Oh, we're graphing it.
Oh, okay. So it's a function. Okay. Good. So let's graph this using transformations. What is the base function, please? Log x. Good. So first transformation.
Wait, is this a number on the packet?
Oh.
I don't know.
No.
My
It's just an example.
down 1. Well,
Left 3.
whatever, yeah.
Log x plus 3, left 3. Good. And now log x plus 3 minus 1, indeed, down 1. Now, what is the domain of this function? What should I write for this to exist? Correct. But what do I have to write? We just solved the log equation about 20 minutes ago. What did we write for that log equation? And we have to write for this function as well. Same thing. Just go back and look what we wrote. Yes, what do I have to write?
X plus 3.
Very good. That's what I want. I don't know why the square root and this function is is creating problems. I have no idea. So then domain is -3 to infinity. And yes, the vertical asymptote is? Of course. Of course. Good. So let's graph log. How do I graph log? Increasing, decreasing on all its domain? Very good. Very good. Because the base is greater, and there is no negative base. The base cannot be 0, cannot be 1. It's only tiny between 0 and 1 or more than 1. What is the base of log? 10. So because the base is greater than 1, the function is increasing. Where does it cross the x-axis? Always the pure log function. Very good. Awesome. Thank you. Indeed, at 1. So this is log x. Excellent. Well done. So now you told me to move it where?
Left 3.
Good. But the vertical asymptote for this function is at 0. I have to move the asymptote first. Awesome. So now, where do I move my indicator? Very good, right here. So this is log x plus 3. And then you told me to do something else with this. You said,
Go down 1.
yes. Down 1. So where does this point go? Right here. So this is the final f of x log x plus 3 minus 1. Well done.
When does it have a vertical and a horizontal asymptote?
Because this is a function with problems, like rational functions. It's not a friendly function. It's not defined everywhere. Exponential is defined everywhere. It still has a horizontal asymptote, but it's defined everywhere. But its range is 0 to infinity. So if the exponential has a horizontal asymptote, its inverse would have a vertical asymptote. Yeah, good question. Okay. And